Hi there, today I'm going to go over muscle contraction and describe it for you. Based on this beautiful picture that I drew, I'm going to go over some parts for you and tell you the specific elements involved or stages involved. Okay, so at the top of the picture we have a nerve cell, and the bottom part is more of a muscle cell. So a nerve cell and a muscle cell. Up at the top here, this is a synaptic knob containing the synaptic vesicles. Okay, the synaptic knob is the nerve cell, and an impulse is going to come through that nerve cell, and it's going to stimulate some calcium to enter into the synaptic knob. Okay, that's going to in turn stimulate these synaptic vesicles, releasing acetylcholine. Acetylcholine is a neurotransmitter that's necessary for muscle contraction. Acetylcholine is therefore released from the synaptic knob. It crosses over this synaptic cleft or space in between the nerve cell and the muscle fiber, and it crosses on to receptors onto the sarcolemma. The sarcolemma is the muscle membrane. Okay, so the acetylcholine will attach itself or bind itself to the receptors on the sarcolemma. That in turn produces something called an action potential, which is represented by these little lightning bolts along the sarcolemma. Okay, that's the action potential that's created. The action potential then goes across the sarcolemma down to across the T tubules, and that in turn, the action potential stimulates the sarcoplasmic reticulum to then secrete calcium, as portrayed by these calciums flipping out of the sarcoplasmic reticulum. Once the calcium is released there, it goes and binds. This is actin and myosin. The actin's the thin filaments, and the myosin's the thin filaments, or thick filaments, excuse me. The calcium will bind to the troponin, okay, which causes the tropomyosin to shift and expose binding sites on the actin itself, okay? And once that happens, then ATP is actually used and broken to ADP and phosphate to use with the myosin. The myosin will use that energy, the ATP, to cock its head, okay, and the myosin will use that ATP to bind to the actin to form a cross bridge, okay? So the heads on the myosin will cock their heads up and attach to the actin, formulating a cross bridge, okay? And then once the cross bridge is formed, the myosin can then shift its head and pull the actin forward, and this is what we call a power stroke. So that forms a power stroke, and after that power stroke, the myosin binds to broken ATP again and starts the whole thing all over again. All the little heads on the myosin bands, there's thousands of those heads. They're not going to all stand up at once and connect to the actin. They don't do so simultaneously. They kind of, trade off. So some are connecting while others are breaking off, and so the process goes on over and over and over again for muscle contraction. Okay? All right, thanks for listening. Bye.